right, I am going to clear up a little bit of a misconception. This is going to be our mini lesson. So today is the second. And this is going to be our mini lesson. All right, in today's mini lesson, what we are actually going to be doing is we're going to be clarifying some of the confusion that we had last class in regards to a chromosome, a chromatid, an autosome, and homologs. All right, so what I've put up here is an image of a karyotype. Right, as you can see by that signifier right there, an X and a Y, we know that this is a male. And if we wanted to look at our karyotype could really kind of help clarify how these words are used. When we talk about our karyotype should have 46 chromosomes. A normal human karyotype has 46 chromosomes. We can break those 46 chromosomes up into discussing that there are 23 chromosomes from mom, and there are 23 chromosomes from dad. This right here would give us 23 homologous pairs. So if we scrolled up, looking at our karyotype, all right, we would have one homolog for mom, one homolog from dad, and together it would give us a homologous pair. So we have 23 homologous pairs. By homologous, we're talking about the fact that they're similar in shape, similar in size, and similar in genetic information. So, in the case of our drawing, all right, we have a homologous pair of chromosomes. All right, when we look at our homologous pair of chromosomes, perhaps, all right, this being dad, this being mom, signified by, difference in colors somewhat, greens and blues for dad, pinks and orangey yellows for mom. So dad's chromosome may have a gene for blue eyes. Mom's chromosome may have a gene for brown eyes. So these two chromosomes are going to be similar. And by similar, I'm talking about the fact that they're both genes for eye color, just a different manifestation of the trait. So they're coding for the same trait, but they're technically different genes. So homologous pairs are going to be similar in their information for various traits. Now, on a different note, if we wanted to look at our karyotype, we could go back to talking about the fact that our karyotype has 46 chromosomes. But this time, instead of talking about the homologous pairs of chromosomes, we can break our chromosomes up differently. We can look at our karyotype and we can say, okay, well, we have a difference. We've got 22 chromosomes that don't really have anything to do with gender. Then we've got one 22 pairs of chromosomes. Then we have one pair that does. So we can turn around and we can say out of our 46 chromosomes, we have 22 pairs of autosomes, which is same as saying 44. Or we have one pair sorry guys, smart words being funny. Of sex chromosomes. And by one pair, I mean it can be either XX, signifying a female, or it can be XY, signifying a male. So, now we've talked about the difference between autosomes, homologs. Let's talk about the idea of chromosome versus chromatid. All right? Each one of these images in our karyotype, I guess figures in our karyotype, can be called a chromosome. On an individual basis, they're each a chromosome. However, on occasion, we do have situations where we can actually talk differently about our chromosome-chromatid combination. What we have here, all right, is going to be a chromosome. All right, so now we're changing our word again, and we're talking about a chromosome. All right, chromosome, this image, all right, or the term chromatid, all right, the word chromatid means that they're identical. So, mom's number one and a copy of mom's number one. Chromatids are copies, right? The word chromatid is only going to come into play when we discuss cellular division. So just know that when I say the word chromatid, a chromatid is talking about an original chromosome and a copy of that original chromosome. They are absolutely identical, or should be absolutely identical in every way, shape, and form. And it is because when the cell divides, each new cell needs to have an exact copy of the genetic information. So hopefully that clears up our confusion about the idea of chromosome, chromatid, autosome, and homologs or homologous chromosomes. If you have any more questions, please make sure that you see me before you have your test.